So thank you so much for having me here today. My name is Krystal Stone. I'm a Bachelor of Science student in Forest Sciences at the Faculty of Forestry with UBC, and I'm supervised by Dr. Lori Daniels with the UBC Treeving Lab, as well as Julie Nielsen, who's a PhD candidate at the SFU School of Resource and Environmental Management. I don't have the right button on my screen to change things. I'm really excited today to actually share with everybody the Seneca Valley Redcedar chronology that we've been developing from 2017 to 2018, as well as introduced a new post-harvest sampling method that we developed to improve the quality of the samples from the trees. So in order to talk about the work that we were doing, I also have to introduce Namaqualis. The Namaqualis Council is a council of 5-member First Nations in Kwakwaka'wakw territory on northeastern Vancouver Island and the southern part of the Great Bear Rainforest. And they've been working on stewardship initiatives for large cultural cedars in their territories and have partnered recently with Western Forest Products as well as Interfor to be able to help protect these resources. Our study sites were located in the Seneca Valley region between Sayward and Was, and they consisted of 9 cut blocks where trees were selected based on size and morphological characteristics that classified them as large cultural cedars as outlined in Namaqualis's Large Cultural Cedar Operations Protocol. So the work that I was doing for the age analysis, as well as a heartwood rot decay analysis, is informing Julie Nielsen's chapter of her thesis that looks at the relationship between the morphology, age, and then the decay within Western red cedar. So the work that I personally got to do as part of this project was our post-harvest analysis, heading up to Western Forest Products cut blocks within months after the trees had been harvested to do the second part of the analysis. Julie Nielsen and her team on the previous years were up in that area doing samples of the live trees and identifying the LCCs to be part of the study. So one of the biggest challenges that we ended up facing when dealing with getting age samples from these trees is that cedars, especially old growth cedars, are notoriously hard to get good tree ring samples from. On the picture on the right here, you can see Julie Nielsen taking an increment bore sample from one of the large cultural cedars. And she said in the message that she sent this image with, while I may be smiling in this photo, it took anywhere from an hour and a half to 2 hours to get the sample out. So being able to get these increment bore samples ends up being incredibly time consuming. And due to the heartwood rot that's been discussed with cedars, you end up getting very poor samples that may crumble or fall apart. And the other concern that Julie ended up having was that if it's during the dry season and these trees have dry heartwood rot, there could be a risk of the friction causing some sort of a fire risk during the summers, even when we have very, very wet climate conditions. And I did forget to mention all the study sites that we're doing for this are mid-elevation coastal western hemlock zone in the Beck system. The other issue that we end up facing is that increment bores tend to be too short to be able to take good samples. Some of the trees that we were dealing with had diameters of over 6.5 feet. So having increment bores that only range from 10 to 100 centimeters just really didn't cut it for the depths that we needed for the samples. And the other issue is if you're taking cookie samples, it's just not practical. As I said, when you have a DBH of 6.5 feet, I don't know if your research project has the budget for it, but I don't think that we could have afforded, a self-loading logging truck to come out there and pick that cookie up and get it back to the lab, never mind get it in a door. So because of these challenges, partnerships between forest research and industry end up being essential in maximizing the game from any sort of forestry operations or harvest, not just through economics, but also through research opportunities. It was actually thanks to the coordination and access provided by Western Forest Products up in the Seneca Valley region that Julie Nielsen and her team, which include Jordan Benner and Namaqualis, were able to collaborate in order to set up research plots that were in regions that were scheduled to be harvested within 1 to 2 years. So this opened the doors for pre-harvest analysis and measurements, and then provide us access to the same trees post-harvest for ring samples and heartwood rot analysis. And this ended up saving a significant amount of time, as well as I'm gonna show you how much we were able to improve the quality of our samples by using the new methods that we developed. So I'm calling our method the V-notch method. Now I know we call tree rings or tree full core sample is a cookie. I would like to call ours the Toblerones because of their shapes. We go out into the woods and we're using a battery powered circular saw, which means that we're able to throw everything into a backpack and head right across the cut box to get to where our sites are. So some of the advantages that we ended up having using this method is that A, it takes so much less time. We have our cordless circular saw, cleaning, doing our measurements, and extracting the sample could be done in less than 15 minutes, which is a huge reduction from the hour-and-a-half marker for some of these old cultural trees. There's no limit to the lengths of the sample, which is great. And we can adjust the width of the sample within reason of the saw to be able to accommodate for either having a wider space around the pith, or if there's any knots or any additional heartwood rot that's on the stump. We're also able to determine the best radii for the sample. So instead of having to take multiple radii, we can quite often look at the tree and find the area that has the most number of intact rings from the bark to the center, and of course include the pith and intersect it if it's present. Finally, we were able to do some great surface area images that we standardized for post-analysis, and these ended up being indescribably useful later on in our age analysis process. So I'm going to show you a couple clips of what it actually looked like out in the field, because it really was a good fun summer being out there. When we located our stumps, cleared off the slash of the logs, we determined the best location to take our radial samples so that we included the greatest number of rings and the least amount of heartwood rock, and if a pith was present, we would intersect it. Next, we would use our circular saw set to a 45-degree angle to remove the V-notch or Toblerone, as I'm gonna keep it up there, sample out of the stump. These wider samples ended up improving the sample quality by quite a lot, as rings that may have been decayed or needed more support had that extra surrounding wood to keep them intact. After that, we secured the samples in aerated plastic corner bead to prevent any warping while they dried over the span of 2 to 4 weeks. And then we measured from the mineral soil to the stump surface so that we could apply our stump height correction estimate for the age of the tree when it was at stump height. And in order to do this, we used Dr. Daniel's age class by height for seedling studies that were done in 1995. And finally, we took our aerial photographs of each one of the stumps. So I'll just describe what we did for the heartwood rot analysis, because I'm not going much further into that for my talk today. But we took our aerial photographs. I used a Garmin camera, but I'd recommend getting a higher quality camera just to get a bit more detail in it. We had a standardizing ruler stick that was on those on each one of the stumps. So when we were able to move it into Photoshop, we were able to measure the pixel ratio to the measurements in the ruler stick so that we had a pixel to millimeters conversion. After we did that, using a mouse and a lot of time, I went and colored in the pixel areas for the surface area of each stump, as well as for the rot, so that we were able to get a bit of our percent rot ratios. And for people who are interested, I do have surface area photos of 90 Western red cedars in mid-elevation zone that have varying degrees of decay from brown rot to white rot. So if anyone's interested in kind of looking at the inside of the trees for any analysis purposes for that, I'm sure we'd be able to share that. Finally, we came back into the lab where we mounted our V-notch samples onto MDF supported backing, and we sanded it down to 400 grit and sanded it in at 1200 DPI before we uploaded it into Coup Recorder and C Dendro to be able to do our age analysis and our cross dating. And so you can see here, here's Julie Nielsen supporting a little bit of UBC swag as she was taking a look at some of the samples that got finished. The image on the right just shows you how clear our samples were for being able to do ring analysis, and the width of the sanded portion, since it's much larger than that of an increment bore, gave us a lot of flexibility to be able to determine whether or not there were 0 rings or any other issues along the rings to make sure that they were all right. Here's an image of just again kind of showing you what the sample looks like in Coup Recorder as we were doing the ring counting. Do not be deceived if you have not done this before. This is sped up 500 times actual speed. It is not this quick, but it does look satisfying when it moves this quickly. All right, So we had our stump heights to be able to do our stump height correction. We used our coup recorder to be able to count the number of rings that were in our samples, but we still had to account for the fact that so many of our trees had heartwood rot, and we needed to be able to estimate how many rings were missing due to that heartwood rot. So out of the 90 trees we ended up sampling, we had 14 that had intact piths that allowed us to create a linear relationship between cumulative ring widths and the number of rings starting from the pith and radiating outwards. So what that ended up creating is our regression linear line on the left here. And this is where using our aerial photographs that were standardized became so handy. So what we would be able to do is we would draw a circle around the area following the concentric rings in the image to estimate approximately where we would assume that the pith would be. We would take the center point of that circle, and then we would measure a pixel line from the center of the circle to the edge of where the ring sample would have been taken. After that, we could convert that number into the number of millimeters, and then we were able to run it through our regression analysis to get an estimate of the number of years that were missing due to heartwood rot. And this is the fun part. So this is my slide that I've done where we're looking at the 90 large cultural cedars that we have. So in the blue here, this is the physical rings that we counted, the number of physical rings per sample. So the average was 461 rings, ranging anywhere from 166 to 873 rings per sample. After we applied our heartwood regression analysis, we had an average adjustment of additional 153 years, ranging from a maximum of 426 years due to heartwood rot down to 0, and those would have been the samples that actually had intact piths. And then finally, we had our stump height correction, which averaged about an additional 31 years, ranging between blocks of 25 and 45 years. So our final age analysis for this thing, for these trees of large cultural cedars in Kwakwaka'wakw territory, averaged 621 years old, and the approximate ages of the trees that we sampled were anywhere from 261 years up to 1146 years. And that kind of blows my mind because we're getting into the point that some of these trees were nearly 300 years older than Notre Dame, just as a European reference, time reference to the age of them. Now, out of that, it's allowed us to build the Sitka Valley chronology for large cultural cedars. So we included the 90 highly correlated samples. And here I'm just going to fade this in. This is my fog of uncertainty because our sample depth after about 1475 dropped down to less than 20. So everything prior to that ended up having at least 20 samples, and above, I believe, the 1500s, we had between 70 and 80 samples. So if we take a look at this area here, I'm going to highlight 3 years. That's 1959, 1921, and 1876. So on our chronology, you can see that the years that I've highlighted are the lowest strip. So what this is the relative average variation in ring widths. I'm losing my ability to say words right now. And I've highlighted them as well in our ring sample. So you'll see 1959, you can see we have a narrower growth signal here where there were limitations. Again, you can see in 1921, we have another limited growth conditions. And this is really fancy actually, because Vanessa's presentation at the beginning talking about yellow cedar decline and that the peak of yellow cedar decline was around the 1880s. Cindy, you brought up how that was kind of interesting. And we actually have one of our biggest climate signals in the red cedars from that region showing a very restricted growth here around 1876. So there must have been some large climate pattern that was affecting multiple species around that time. We haven't had a chance yet to do any sort of climate analyses on this. That is what the goal is going forward for different conservation purposes. So as I mentioned, I'm an undergraduate student and using all the data that we've collected from this. What I'm hoping to do is move forward to ask the question, what extent broad scale climate oscillations are detectable in these mature red cedar growth patterns? And it ends up being really important because it's going to help us understand the climate factors that impact established red cedar forests so that we can improve any sort of conservation and management efforts. And this will kind of give us an idea where declines may be planned to happen, as well as where red cedar is going to continue to expand into, as we've seen in previous presentations. So hopefully I managed to do that in 10 to 15 minutes. Gila Kessler, thank you for letting me be here and speak, and I can take any questions.